Hello everyone. Welcome back to the lecture series of ICSE 10th Maths chapter Proportions. We were doing the sums from ML Aggarwal. In our previous lecture, we did the sums till question number 21. Today we are going to start from question number 22. There are only two questions remaining from this chapter now. As I told you that question number 22 and question number 23 have few sub-questions. So let us do that and we will be completing with this chapter. My name is Arpita Banerjee and you are watching Arpita Classes. Let's get started. So question number 22 says A, B, C are in continual proportion. Prove that the first part is A plus B upon B plus C is equal to A square whole into B minus C divided by B square whole into A minus B. Let us do this. First of all, A upon B will be equal to B upon C and that should be equal to another constant, that is K, because they are in continued proportion. So from here we'll get A is equal to BK and B is equal to CK. So once we put the value of B over here, we'll be getting CK square. Till this we have already done. In the previous questions also we got this. So B is equal to CK and A is equal to, B is equal to CK and A is equal to CK square. We got this, right, from this. Now, the first part is left hand side you have A plus B upon B plus C. So we are going to substitute the value. In place of A we are going to write CK square plus B is CK divided by CK plus C. Now from here in the numerator we can take CK common. So it will be K plus 1. Down we can take C common. We get K plus 1. So from here C and K plus 1 gets cancelled. We get only K from the left hand side. Similarly, let us process the right hand side. In the right hand side we have A square whole into B minus C divided by B square whole into A minus B. Let us substitute the values again. A square would be CK square the whole square. B is CK minus C divided by B square, that's CK square whole into CK square minus CK. Now this will be C square K to the power 4. From here we will take C common, so it will be K minus 1. Down we have C square K square. From here we can take CK common, so it will be K minus 1. Now let us see what is getting cancelled. K minus 1, C square. Here K square and K cube, and this is K, so K will be remaining in the numerator and C also gets cancelled, so we are getting only K in the numerator. So here we can see left hand side is equal to right hand side, that is proved. So we proved the first sub question, this is proved. So basically this method only we have to use for rest of the sums also. We got the value of A CK square and B CK, and those values we have to put in place of AB and we have to take common and see how it is coming. Okay. So let us solve the next question also. Question number 2. Question number 2. The left hand side we have 1 upon A cube plus 1 upon B cube plus 1 upon C cube. Now 1 upon A cube is 1 upon CK square the whole cube plus 1 upon CK the whole cube plus 1 upon C cube. So 1 upon C cube into K6 plus 1 upon C cube into K cube plus 1 upon C cube. Now let us take the LCM over here. The LCM will be C cube K6. So it will be 1 plus K cube plus K6. So we are getting from here, that is K6 plus K3 plus 1 divided by C cube K6. Anything is getting cancelled? No. So we are getting this from the left hand side. Let us write down this here so that we remember what we get from the left hand side, as I need to rub this. This we are getting from the left hand side. Now let us process the right hand side and see whether we are getting the same thing from the right hand side or not. Take right hand side, A upon B square C square plus B upon C square A square plus C upon A square B square. So A is CK square upon B square is C square K square into C square plus b, that is c square, b is ck divided by c square whole into c square and k4 plus c divided by c square k4 into c square k square. So it is ck square c to the power 4 k square plus ck c to the power 4 k4 plus c to the power 4 k6. So if I take the LCM, it will be c to the power k4 k6 is LCM. So here I get ck square into k square, k4, k to the power 4 plus c4 k4. So here I get ck into k square plus c into c, that's all. So here c k to the power 6 plus c kq plus c divided by c4 k6. I can take c common from the numerator, so I get k6 plus k3 plus 1 divided by c4 k6. Here it gets cancelled, we get ck. So now if you compare with the left hand side, from the right hand side also we got k6 plus kq plus 1 divided by cq k6. So if you compare with the right hand side, we are getting the same thing in the left hand side and in the right hand side. So the second question is also proved. Okay, let us proceed to the next question. Now I am just rubbing this part because we do not have much space over here. So just remember that we have A is equal to ck square and B is equal to ck. These two things we need to remember. So I am rubbing this part also. So number 3, question number 3, in the left hand side we have A is to C. So A is ck square, put it here, ck square is to C. That means ck square upon c. From here we get only k square from the left hand side. Right hand side, in the right hand side we have a square plus b square is to b square plus c square. So that means a square plus b square upon b square plus c square. So in place of a square we are going to put ck square square, that is c square k to the power 4 plus b square is c square k square, c square k square plus c square. From the numerator we can take c square k square common. So it is k square plus 1. From down we can take c square common. So it is k square plus 1. This is getting cancelled, this is getting cancelled. We are getting k square from the right hand side. Therefore we can write left hand side is equal to right hand side. That's the third sum. Okay. Let us proceed to the next question. Question number 4. You can pause the video and can do the sums if you are not able to do along with me. You can pause the video. Question number 4. A square b square c square whole into a to the power minus 4 plus b to the power minus 4 plus c to the power minus 4. Okay, so this is your left hand side. So a square b square. Now first of all, a square b square c square. A to the power minus 4 is 1 upon a to the power 4 plus 1 upon b to the power 4 plus 1 upon c to the power 4. So first of all we are going to take LCM over here. This is A4, B4, C4 is the LCM. So here we get B4, C4 plus C4, A4 plus A4, B4. This will get cancelled. Here we'll get A square, B square, C square. So we get B4, C4 plus C4, A4 plus A4, B4 upon A square, B square, C square. Now let us put the values. B4 will be C to the power 4, K to the power 4 into C to the power 4 is there plus C4 into A4 is C to the power 4, K to the power 4 2s are 8 plus A4 again C to the power 4, K to the power 8 into B4. B4 is C to the power 4, K to the power 4 divided by A square. A square is C square, K to the power 4. B square is C square, K square into C square. So from here I am getting C8 K to the power 4 plus C8 K to the power 8 plus C8 K to the power 12 divided by c square k4 plus into, so this we can multiply c square into c square into c square is c6 k to the power 6. Now let us see what we can take from the numerator. C8 is common everywhere and K4 is common, so we can take C8 K4 common. So we get 1 here plus K to the power 4 here plus K to the power 4 we have taken 4 we have taken, so 8 K to the power 8 divided by, we have C6 and K6. So this will get cancelled, this is C square, this will get cancelled, this is K square. So from the left hand side we are getting, where should I write? Is it visible? Yeah, so I am writing here, from the left hand side we are getting C square whole into K8 plus K4 plus 1 divided by K square. This we are getting from the left hand side. Now let us see the right hand side. Let us proceed with the right hand side. Okay, so the right hand side is b to the power minus 4 whole into a4 plus b4 plus c4. So it is 1 upon b4 into a4 plus b4 plus c4. So a4 will be c4k8 plus c4k4 plus c4 divided by b4 is c4 k4. From here I can take c4 common, so it is k8 plus k4 plus 1 upon c4 into k to the power 4. So this will get cancelled. It's only k to the power 4 here. So what we can do is, we got the numerator C is equal to K upon B. Okay, let us start with question number 4 now. The sub question 4, we have in the left hand side a square, b square, c square whole into a to the power minus 4 plus b to the power minus 4 plus c to the power minus 4. So in the first step I will write 1 upon a to the power 4 plus 1 upon b to the power 4 plus 1 upon c to the power 4. Now I will split it up, a square, b square, c square upon a to the power 4 plus a square, b square, c square upon b to the power 4 plus a square, b square, c square upon c to the power 4. What did I do? This upon this plus this upon this plus this upon this. Now this is getting cancelled here, this is getting cancelled and this is getting cancelled. So I am getting b square, c square upon a square plus a square, c square upon b square plus a square, b square upon c square. So now let us put the values. B is ck, so c square k square into c square upon c square k to the power 4 plus c square k to the power 4 into c square upon c square k square plus c square k to the power 4 into c square k square upon c square. So from here this is getting cancelled, this is getting cancelled, so I am getting c square upon k square plus here this is getting cancelled and I am getting 6 square into k square plus this is getting cancelled, so c square into k to the power 6. So if I take c square common from the numerator, okay, here I get 1 upon k square plus here k square plus here k to the power 6. So if I write it in a proper manner, I get c square, then k to the power 6 plus k to the power square plus k to the power square plus this, if I take it up, it will be k to the power minus 2. So this is what I get from the left hand side. Let us write it here, k to the power square plus k to the power minus 2. This is from the left hand side. Now let us proceed with the right hand side and see whether we get the same thing or not. So the right hand side is b to the power minus 2, a4 plus b4 plus c4. So b to the power minus 2 is 1 by b square A4 plus B4 plus C4. So this can be written as A4 upon B square plus B4 upon B square plus C4 upon C square. So A4, this is getting cancelled, this is B square only. A4 can be written as C square k to the power 8 upon C square k square plus B square is C square k square plus C4 and this is B square. So C to the power 4 and this is C square k square. So here C square and this is k to the power 6. So this k to the power 6 plus C square k square plus A4 is C square into k to the power 4 and B square is C square k square. C square getting cancelled. So here it is C square upon k square. Here one C square has to be there. A4 upon k square. A4 is C to the power 4. Sorry. Here is the mistake. A4 it is. A4 is C to the power 4 and k to the power 8. Here is the mistake. So it will be C square and this will get cancelled. So it will be C to the power 2. C square will remain here. Okay. So now from the numerator, if you take C square common, it is k to the power 6 plus k to the power 2 plus 1 upon k square. And if you take k square up, it will be 6 square whole into k to the power 6 plus k to the power 2 plus k to the power minus 2. Now if you see the left hand side and right hand side, we are getting the same thing. Therefore, we can write left hand side is equal to right hand side proved. So we finished with the fourth sum also. Now let us proceed towards the fifth sum. Everyone understood the concept, so you can just pause the video, you can try the sums on your own. Let us start with the fifth question. The left hand side, we have A, B, C whole into A plus B plus C, the whole cube. So let us put the values directly. A is ck square into B is ck into C. Here it is ck square plus ck plus C, the whole cube. So we are getting C into C into C, that's C cube, k square into k, that's k cube. You take C common from here, it will be k square plus k plus 1 and this whole thing has a cube. So we are getting C cube, k cube, this is again C cube, k square plus k plus 1, the whole cube. So C cube and C cube will give me C6 k cube whole into k square plus k plus 1, the whole cube. So this is what we get from the left hand side. Let us see what we are getting from the right hand side. Right hand side we have AB plus BC plus CA, the whole cube. So AB is A is ck square into B is ck plus ck into C plus C into ck square, the whole cube. So here it is C square k cube plus C square k plus C square k square, the whole cube. So if I take C square common from here, I get k cube plus k square, the whole cube. This whole thing has a cube. So now C cube whole to the power 3 is C to the power 6 and this is again k cube plus k square plus k, the whole cube. Okay, so I can take even a k common from here. I can take a k common from this. It is C to the power 6, k common, so it will be k square plus k plus 1 and this whole thing has a cube. So finally we get C6 k to the power cube whole into k square plus k plus 1 whole to the power cube. Now if you look at the left hand side, C6 k cube, k square plus k plus 1 whole cube. In the right hand side, C6 k cube, k square plus k plus 1 whole cube. So we got the same thing. Therefore, left hand side is equal to right hand side. We did the fifth question also. Let us proceed with the last question of question number 22. That is question number 6. We have in the left hand side A plus B plus C whole into A minus B plus C. Let us put the values. A is ck square plus ck plus C whole into ck square minus ck plus C. Take C common from here, k square plus k plus 1, C common, k square plus k square minus k plus 1. So c into c is c square, and then we have k square plus k plus 1 into k square minus k plus 1. Let it be till here. Let us see what we are getting from the right hand side. We have a square plus b square plus c square. C square k4 plus c square k square plus c square. So if I take c square common, it is k4 plus k square plus 1. That means here we need to do something so that we get this thing. So let us solve this further. From here, where should I write? Okay, I'm just writing this part. So now you can see from here I am going here, okay? From you can see this is k square plus 1, k square plus 1. Okay, so we'll take that as a term. So k square plus 1, and then we have here plus k, okay, and into k square plus 1 minus k. So if you see this, it is a plus b into a minus b, which is your a square minus b square. So now expand it, k4 plus 2k square plus 1 minus k square. So finally we get k4, 2k square minus k square is plus k square plus 1. Now you look at the right hand side and the left hand side, we got the same thing. So we can write left hand side is equal to right hand side. So basically we use this formula a plus b into a minus b to get it equal with the right hand side. So that's our sixth sum. So we completed with the question number 22 here. Now we are left with the last question, that is question number 23. Let's get started. Question number 20. So question number 23 in front of you. The first is given that A, B, C, D are in continuous proportion. So I'm just doing it here because this has to be there throughout. Okay, so A upon B is equal to B upon C is equal to C upon D is equal to K. Because A, B, C, D are in continuous proportion. So A is equal to BK, B is equal to CK, C is equal to DK. Now here B is equal to CK and C is equal to DK. So put C's value here. So it will be DK square. And once we put B's value here, it will be DK cube. So A we are getting DK cube, B we are getting DK square, and C we are getting DK. Just remember these three values. We are going to use these three values. Now let us take the first sub question, the left hand side. A cube plus B cube plus C cube upon B cube plus C cube plus D cube. This is your left hand side. Now A cube, A is DK cube. So in place of A cube it will be D cube k to the power 6 plus B cube, so it will be D cube k to the power 6 k square, B cube. Let us write it one more time because it's confusing. dk cube the whole cube plus B is dk square the whole cube plus C cube is dk the whole cube divided by again B cube, so dk square the whole cube plus dk the whole cube plus d cube. Okay. Now this will be d cube k to the power 9 plus d cube k to the power 6 plus d cube k to k cube divided by d cube k to the power 6 d cube k cube plus d cube. Now let us take common whatever we can take common from the numerator. We are getting d cube into k cube. So k to the power 6 plus k to the power 3 plus 1 divided by down we have d cube common, so k to the power 6 plus k to the power cube plus 1. This whole thing getting cancelled, d cube getting cancelled, we are getting only k cube from the left hand side. Now let us take the right hand side. Right hand side says very simple, a upon d. So a is dk cube divided by d. d gets cancelled, we get k cube. So we can say left hand side is equal to right hand side. Okay, the first question is done. Let us start with the second sub question. The second sub question is a square minus b square c square minus d square is equal to b square minus c square the whole square. So this is your left hand side. This is our left hand side. So a square is dk cube the whole square minus dk square the whole square. This is your a square minus b square into c square is your dk the whole square minus d square. Okay, now this is d square k to the power 6 minus d square k to the power 4 whole into d square k to the power square minus d square. So from here I can take d square k to the power 4 common. So it is k to the power 2 minus 1. And from here I can take d square common, so k square minus 1. So I can write d4 k4 and k square minus 1 the whole square because it is 2 times given. Now let us take the right hand side. It's b square minus c square whole square. B square will be dk square whole square minus dk whole square. This whole k square. So we have b square k to the power 4 minus b square k square, this whole square. So if I take d square and k square common, it is k square minus 1, this whole square. So it is d4 k4 and k square minus 1 the whole square. Now if you look at the right hand side and left hand side, both are same. So we can say left hand side is equal to right hand side. Okay? The second question is also done. Now let us go for the third question. Okay, so the third question, left hand side we have a plus b, b plus c minus a plus c, b plus d. So a is what? dk cube, put it here, dk cube plus d, b is dk square plus dk minus dk cube plus dk, dk square plus d. So from this we can take d common, k cube plus 1, here dk common, k square plus 1, minus dk common, k square plus 1, d common, k square plus 1. Yes. So now dk k square plus 1, dk k square plus 1 and d is again common. So d square into k square plus 1 I take common. So here I have only k cube plus 1 minus, here I have k square minus 1. So plus 1 minus 1 will get cancelled. So I get d square k into k square plus 1 into k cube minus k square. From here again I can take k square common. If I take k square common, it is k square minus 1. So d square k into k square is k cube. K square plus 1 into k square minus 1 will give me k4 minus 1. K plus b into a minus b. Okay, so that is your left hand side. Let us take the right hand side and see what we are getting. B minus c the whole square. B is dk square minus dk the whole square. Dk if I take common, it will be k minus 1 the whole square. So that gives us d square k square into k minus 1 the whole square. Something went. So let's start with the third sum now. The third question, left hand side we have a plus b into b plus c minus a plus c into b plus d. Let us put the values. A is dk cube, so it is dk cube plus b into dk square plus dk minus dk cube plus dk, dk square plus d. Let us take common. Here it is d common, k cube plus 1. Here dk common, so k square plus 1. Minus here dk common, so k square plus 1. D common, k square plus 1. Now d into dk is d square k, and then you have k cube plus 1 into k square plus 1. Minus Here also d square k, k square plus 1 the whole square. Okay, now let us multiply these two. It is d square k, k cube into k square. Oh, I have taken dk common, so this will be k plus 1, not k square, k plus 1. Because I have taken dk common from here, so it will be k plus 1. Okay, so k cube into k is k4 plus k cube plus k plus 1 minus d square k. Let us expand this a plus b whole square formula, k4 plus 2k square plus 1. Now I am taking d square k common. So k4 plus k cube plus k plus 1 minus k4 minus 2k square minus 1. So k4 and k4 gets cancelled. 1 and 1 get cancelled. So d square k whole into k cube minus 2k square plus k. So d square k, if I take k common from here, so it will be k square minus 2k plus 1. That will give you k minus 1 the whole square. So this is what we get from the left hand side. I'll just write it down here so that we remember d square k square into k minus 1 the whole square. Now let us see the right hand side of the same question. So the right hand side is b minus c the whole square. So b is dk square minus dk the whole square. I take dk common from here, so k minus 1 this whole square, so that gives you d square k square into k minus 1 the whole square. Look at this and this, we get the same thing from left hand side and right hand side. So that is good. So this is the way we have to prove the sums. I have done till question number 3. Question number 4 and 5 you can try at home. So the same concept, in place of a, b and c you have to put these values, take common, whatever is getting cancelled, cancel it out, and then whatever you simplify the rest of the things. Okay, I'll show you one more sum, the 5th one, because it looks difficult. So I'll show you the last sum. That's the 5th one. A minus b upon c plus a minus c upon b the whole square minus d minus b upon c plus d minus c upon b the whole square. So a is dk cube minus dk square upon dk plus dk cube minus dk upon dk square whole square minus d minus dk square upon dk plus d minus dk upon dk square whole square. From here I can take dk square common, so I get k minus 1 upon dk, okay, plus dk common, so k square minus 1 upon dk square. This whole thing has a square. D common 1 minus k square upon dk plus d common 1 minus k upon dk square whole square. D, k, and this is k only. So k whole into k minus 1 plus d gets cancelled. So it is k square minus 1 upon k. This whole thing has a square. Here d gets cancelled. So it is 1 minus k square upon k plus d gets cancelled, 1 minus k upon k square the whole square. Let's take k LCM over here. So it will be k square into k minus 1 plus k square minus 1 whole square. Here k square is the LCM, so k whole into 1 minus k square plus 1 minus k the whole square. Now this is k cube minus k square plus k square minus 1 upon k the whole square into k minus k cube plus 1 minus k upon k square the whole square. Here k square gets cancelled. So we are getting k cube minus 1 upon k, the whole square. And here minus k plus k is getting cancelled. So 1 minus k cube upon k square, the whole square. So if you see, this is k cube minus 1, this is 1 minus k cube. Both of them are having square. So we can reverse it and we can write k cube minus 1. The bases are same, powers can be added to the power 4. And this is k cube. So we get k cube minus 1 to the power 4 upon k cube from the left hand side. I'll just write it down here. No, sorry, this is a square and this is a4. A to the power 6 it is. A to the power 6. K cube minus 1 the whole 4 divided by k to the power 6. This is what we get from the left hand side. Now let us proceed the right hand side. So in the right hand side we have a minus d whole square whole into 1 upon c square minus 1 upon b square. So a is dk cube minus d whole square 1 upon b square k square minus 1 upon b square k4. b common k cube minus 1 this whole square. Here I take b square k4 as LCM, so it will be k square minus 1. Now it is b square k cube minus 1 whole square k square minus 1 upon b square k4. This square and this square get cancelled. This is k cube minus 1 whole square, this is k square minus 1. So this is k cube minus 2k cube plus 1 into k square minus 1 upon k to the power 4. Minus 1. Something is wrong over here. Let us see. Let us do one thing. A minus d whole square. So the last question of question number 23, that is a minus b upon c plus a minus c upon b the whole square is equal to b minus b upon c plus b minus c upon b the whole square, and that should be equal to a minus b the whole square upon 1 upon c square minus 1 upon b square. This we need to prove. So first I'll take the left hand side. A is dk cube minus dk square upon dk plus dk cube minus dk upon dk square the whole square. Here this is minus 1. Now d minus dk square upon dk plus d minus dk upon dk square the whole square. Here I can take dk square common, so it is k minus 1 upon dk plus dk common, so k square minus 1 upon dk square. K square minus 1. Taking dk common, so k square minus 1. Whole thing square. D common 1 minus k square upon dk plus d common 1 minus k upon dk square. This whole thing square. There is a minus sign over here. Minus sign. So now dd, this is k. So k going to k minus 1. dd gets cancelled. This is k. K square minus 1 upon k whole square minus, this is 1 minus k square upon k plus 1 minus k upon k square. This is LCM over here, k into k, k cube minus k square plus k square minus 1
whole square minus k square is the LCM here. So k minus k cube plus 1 minus k the whole square. This is getting cancelled. K cube minus 1 upon k the whole square minus, here k and k gets cancelled, minus k cube plus 1 upon k square the whole square. So here this is k cube minus 1 the whole square upon k square minus, since this is square I can just reverse it. I can write k cube minus 1 the whole square upon k to the power 4. So now if I take k cube minus 1 the whole square common upon k square common, so it will be inside the bracket, it is 1 minus 1 upon k square. So that is k cube minus 1 the whole square upon k square, k to the k square, and here it is k square is the LCM, k square minus 1. So finally I get k cube minus 1 the whole square upon k to the power 4, and here k square minus 1. So this is what I get from the left hand side. Now let us proceed the right hand side and see whether we got the same thing or not. Okay, I'll just rub the whole part. We'll keep the last part only. So the right hand side is a minus b the whole square 1 upon c square minus 1 upon d square. dk cube minus d the whole square 1 upon d square k square minus 1 upon d square k to the power 4. d common, k cube minus 1 the whole square. Here d square k to the power 4 common, so it is k square minus 1. So it's d square k cube minus 1 the whole square into here k square minus 1 upon d square k to the power 4. d square is cancelled. So it's k cube minus 1 the whole square into k square minus 1 upon k4. Now if you look at the left hand side, what we got, k cube minus 1 the whole square, k cube minus 1 the whole square into k square minus 1 into k square minus 1 divided by k4 divided by k4. So we got the same thing from the left hand side and from the right hand side. Therefore we can say left hand side is equal to right hand side.
So with this last sum, we have completed the whole chapter proportion from ML Aggarwal. Now in the next video, I am coming up with the sums from chapter banking. So that is on request. I'll be starting with banking chapter. No, not really banking, GST. The GST chapter I'll be starting in the next video. Banking is already done. So GST will be starting in the next video. Thank you so much. Stay.